Today we are using our Darex XT3000 to sharpen a carbide drill. But first let's take a look at a couple of things we need to consider when working with carbide drills. Many of the carbide drills that we may wish to sharpen are of the common shank variety, where the shank diameter is actually larger than the flute diameter. This can make them very awkward to grip in the standard chuck. As you can see, the jaws of the chuck are quite long and won't allow enough of the drill to stick out of the front of the chuck while still gripping on the flute in front of the shank. Fortunately, Darex can supply a special chuck designed for these common shank drills as well as Morse taper drills. This chuck has extra relief in the jaws to allow for the larger shank. The next thing we will need to consider is the grinding wheel we will use for carbide. Darex can supply two different wheels to suit the XT3000, one of which has a CBN coating and the other has a diamond coating. For sharpening carbide drills, we absolutely must use the diamond wheel, which is easily identified. So now we can commence changing the wheels over by first isolating the machine from power and then removing the primary grind station so that we can remove the screws and cover plate and gain access to the grinding wheel. Now we can remove the 3 screws in the grinding wheel retainer, which can then be removed. Once the retainer is removed, the wheel can be maneuvered out of the opening, which I find is easiest with 2 thumbs. Once the wheel is removed, the spindle end must be cleaned very thoroughly before the new wheel is installed, ensuring it is seated correctly. Then the wheel retainer can be reinstalled and carefully lined up with its mounting screw holes and the screws replaced. This should be done with care to ensure that the wheel locates correctly, and the wheel should be checked for runout before it is fully tightened down, after which the cover can be replaced and the primary grinding station reinstalled. Now that we have our diamond wheel installed, we can set the machine up to the appropriate settings for the drill we want to sharpen. In this case, we have a 135-degree point angle, so a good start point is to set all of the machine's main settings to 135. And now we are ready to sharpen our drill. We'll do this in real time, starting as always with the setting station to position the drill appropriately in the chuck, followed by the primary grind station where we create the primary point geometry. Here we continue to rotate the drill in the chuck until it's no longer removing material. In this way we ensure that the point has the correct geometry. And then we finish the process in the point split station by splitting first one side of the point, and then the other. And this is the resulting drill point. As can be seen, it looks well centered, has adequate relief, and has been split all the way to the center, providing a very high quality point which will no doubt drill on size.